Okay, this was from 1709-12, I believe. What we're doing is, I believe this is the first problem. Question mark, because I haven't consulted the document, and that was yesterday. Okay, so what you were asked to graph y equals x squared. That's an easy graph. We know what it looks like. And then to estimate the average rate of change of y with respect to x, or to sketch the appropriate parts of the graph that relate to the question of the average rate of change of y with respect to x on the interval, x interval, from 0.7 to 1.2. Okay. So the first thing we asked was, well, where's the x interval? Okay, well, the x interval is here. It goes from 0.7 to 1.2. Okay, then the average rate of change is what? Well, I define that to be the slope of the segment between the graph points that correspond to the endpoints of that interval. Now, we'll deconstruct that sentence in a minute, or that phrase at least. So, that corresponds to a fundamental triangle that approximates the graph. So, when x is 0.7, the y value is whatever it is at this point. Now, we started by not worrying about what the numbers were. After we got to 0.7, the 1.2, we just, okay, right there is the graph point for x equals 0.7. We know that the y coordinate is going to be f of 0.7, and of course we can evaluate that. But we're not doing that yet. We want to draw the triangle, and then we figure things out. Okay? When x is 1.2, the other endpoint, so, okay, here's your interval from 0.7 to 1.2. We evaluate the function at this endpoint of the interval, or we locate the point corresponding to this endpoint of our x interval, and then corresponding to this point, we get a point directly above that on the graph. Then we draw the segment, and we complete our fundamental triangle, and right there it is. There's a picture of the fundamental triangle whose slope represents the average rate of change of this function, f of x equals x squared, with respect to x. So, slope is the average rate of change of x squared with respect to x on the interval 0.7, 1.2. Now we can do a little calculation, okay? Well, first of all, a fundamental triangle is defined by 2 points, the 2 endpoints of this sloping segment. The 2 points, the 2 points that define the fundamental triangle. What are the coordinates? Well, 0.7, f of 0.7, right? F of x. This is an f of x function. Now this is true for any function. It doesn't have to be the x squared function. In the next step, where we start evaluating f of 0.7 and f of 1.2, then we use the specific function. But for any function, the fundamental triangle points is defined by the points. The fundamental triangle corresponding to the x interval, 0.7, 1.2, this interval is 0.7 f of 0.7, 1.2 f of 1.2, because f of 0.7 is the y value at this point, f of 1.2 is the y value at this point, and those are the y coordinates. Okay, so our coordinate here is 0.7 f of 0.7. Our coordinate here is 1.2 f of 1.2. Now we evaluate, okay? Again, everything I've said so far would apply to any function whatsoever. For the specific function, the x squared function, well, f of 0.7 is 0.7 squared, f of 1.2 is 1.2 squared. Now, yeah, commented on, I certainly expect you'll be able to square 0.7 mentally, or at least on a piece of paper. It's 0.49. And unless you've had gross experiences in your life, you might not be able to square 1.2. But 12 squared is 144, 1.2 squared is 1.44. And 12 squared would be a dozen dozens, and that's a gross. That's a definition of the word gross. It means a bunch of stuff. Okay, so anyhow, 1.2 squared is 1.44. So there are the 2 points. Now we want to get the specific result. We make a bigger picture of our fundamental triangle and label the points with the numbers, 0.7, 0.49, 1.2, 1.44. And you see on the graph I've indicated that the 0.49 is here on the y-axis and the 1.44 here between 1 and 2, a little closer to 1. Okay? So we understand all of that. So now we want to get the slope. Well, the rise is how far we have to go up from here to here, so that's going to be this minus this, 1.44 minus 0.49, 0.95. And the run is going to be 1.2 minus 0.7 equals 0.5. So our slope is rise divided by run, 0.95 over 0.5, which is 1.9. We then conclude that the average rate of change, now I abbreviated it, it's the average rate of change of x squared with respect to x on this interval is 1.9. That's it.